Hello everyone, welcome back. So in this video, we are going to understand the LeetCode problem number 1582 as you can see here. So in this video, we will understand how to implement this solution and we'll understand the intuition and the approach. But before that, imagine you are given a binding matrix and just you have given zeros and ones, right? That is called the binding matrix. And your task is to find a position that is the only one in its row and the only one in its column. Sounds easy, right? Wait until you try the brute force and realize you are wasting your time. Today, we are breaking down this problem in very simple steps. So let's try to understand the intuition and interview ready approach. So what we have given here is we have given this binary matrix we have given, and there is a position we have given, let's called I and j. Okay, so there is a position we have given I and j. It is called a special if matrix at I and j means the given, if this is a matrix at I and j is equal to 1. This is what it is saying, right? If a position ij is equal to 1 is called a special if the matrix I and j means the a cell having 1 and every other element in that row is 0 and every other columns in j is 0, means the row I contains all other 0 and the column j contains 0 and the element at that cell we have 1. So for example, if you talk about this cell value, this is having 1 and in this row all are zeros and in this column all are 0, but this cell contains the value 1. That is why this is a special, right? This position is a special. Now try to understand in simple words. So a special position is lonely one, we can say. What? Lonely one. If we have lonely one in both row and column, can we say that? Right? If there is only one in both row and column, simply means that is a lonely one in a special position, right? Our task is to count how many such position exist. How many such position exists, right? Means the special position, lonely one, right? That we need to find here. So let's try to understand, break it down this problem, and we'll try to understand in a simple language. Okay, so let's start from here. We'll take an example, right? So we want to take an example. Give me 1 second, guys. Yeah, so we'll take an example. So in example, let's take, we have a matrix. So this matrix contains what? Some value 1 0 0, then we saw that 0 0 1, then we have 1 0 0. Like this we have given a matrix, right, in example 1. So we'll use this same example and we'll try to understand this. So let's suppose this example we have given here. If we'll talk about the columns, what are the columns we have? Column 0 we have, column 1 we have, column 2 we have. Here row 1, row 2 and row 3 we have given, right? Like this means row 0, row 1 and row 2 we call like this, right? This is, we can say, if we'll try to understand a matrix, right? This is what we have given. Let's let's think that we will take some steps. So step 1 will say, okay, let's check the cell 0 0. What we have 0 0. So 0 0 is here, is we are talking about all the cell starts with the very first beginning, that is coordinate in the coordinate system or in the matrix system is 0 0, right? So if we'll talk about this one, it means we are talking about this row first, correct? So we'll say, okay, in this case, row 0 we are talking about, where we have elements 1, 0, 0, correct? This is the three elements we have given in this row. We can say there is only one, only one is there, only one, one is there, right? We can say it is correct, right? Now let's talk about the column. Now if we'll talk column 0, it contains three element, 1, 0, and 1, like this, right? We can say means we are talking about this cell. Here the problem is there is not only one, but there is two. One is there, or oneness, we can say oneness, right? We can say. Give me 1 second, guys. One s, like that we can say it is not acceptable. This is not valid, right? This is not special. So we can say that it's not special cell. We can say that, right? Not special. Okay. Let's move to the next one. So we'll move to the next one. We'll check 1, 2 here now. So step 2, we'll say step 2, check 1 and 2, right? Coordinate 1 and 2. So if we'll talk about 1 and 2, it means we need to check row 1. We are talking about row 1 where we have three elements we have given. Let's call 0, 0, and 1, right? If you see here, we have 0, 0, 1 in this row, correct? Here we have only one, only one, we can say, right? Means this is correct. Let's talk about the column 1. No, not column 1, column 2 it will be there, right? Here we have element 0, 1, 0. This is what we have seen, right? 0, 1, 0. Yes, we are talking about the last one, because this one we have 0, right? So we have took this one, this cell where 1 is there, that we will check only, right? So if you observe here, it was 1, then we have took the steps, then we have checked this one, like that we will check, right? So this is correct. Now we will check here, means we have only one, right? So this is also true, means this is special. This is special cell, we can say, a special position, we can say. Let's talk about the last one. We are talking, let's go with the last one that contains this one, right? Sorry, guys. So step 3 we will say, and we'll say let's check 2, 0. At 2, 0 we have 1, right? Means we are talking about what? We are talking about row 2 where we have seen 1, 0, 0. Correct, guys? So how many 1s is there? There is only one 1s is there. Only one s is there. It is correct. But in column 0 we saw that there we have 1, 0, 1, right? And 2 1s is there, so it's not valid. So it is not special, right? I hope you understand. So very first we have took this matrix, guys, right? So in this matrix we have, these are called columns and these are called rows, right? So three columns, three rows we have given. So we will check, we will scan this array, right? And we'll check where we have one. At that position we'll check with, we have 3, 1, right? So we'll take 3 steps, right? to understand each step that it is special or not. So very first we have 1 at 0 0, where we have the rows is 1 0 0 and the column is 1 0 1. If there is two ones are there, means this is not special. So we'll check second position where we have 1 at 1 2, means we are talking about this one. So this cell we saw that the in the row 1 and column is this one, right? So both places we have 1 1 s, right? So this is special. But in the step 3 we found that there is another one is there at this position here in the column 1. We saw that 100, sorry, column 2 is row 2 is 100. So this is 1s, but column 0 contains this one, so this is not special. So we can say that final answer will be there is only one s is there in step 2, and that is why this is our answer, right? I hope you understand. The question is why the brute force approach is not smart here, right? Because if you observe this approach, right, the we found one is right. So for every one, we have to scan entire row and we have to scan entire column. And so if we'll do that, we know that the time complexity, if we'll scan here, then we'll go for here, right? Means we know that the time complexity, because what? If row and column is there, right? We know that m cross n will happen, m cross n, and we have to also multiply for m plus n, right? So this becomes little we can say unnecessary repetitions. Due to that, we can do better, right? So we should optimize this approach rather than going with the brute force approach, and we should try something instead of repeating this scanning row and columns, right? We will create two arrays, right? Let's call for the row count that contains uh, number of oneness in a row, right? In row I, we can say, and column at j, right? Number of oneness in the column j, and we'll scan the matrix, right? We will scan the matrix and we'll fill the count, right? In step 3, what we should do is we should scan the matrix again. We'll check if matrix at ij is equal to 1, means is the row count at I is equal to 1, right? If it is equal to 1, we'll check the column count is equal to 1. If both are same, right, then it means we will increment the answer, right? That's it. It's not repeating scanning. So we'll return finally the incremented answer, and that's what we will do this, right? So the very first thing is that why this approach will work, because a row must contain exactly one, right, and a column must contain one, right? So if it is not the condition is there, right, it means it's not valid one, right? It means if this is containing in the row and in the column, means this is a special one, right? So if both condition holds, it must be special, and that is why the time complexity in this case become O of m cross n, we can say. And for the space complexity, it become O of m plus n. So that is very interview friendly approach that we can say is very clean and inefficient, right? So let's try to understand how we can write this code cleaner and efficient. Okay, let's try to understand. What we have given the matrix mat, right? So what we should do here is we should take two variable. Let's call int m equal to this mat we have given, mat dot length will do, and we'll find the mat. Then we'll create int n, the the row and columns, right? So we'll say okay, mat at 0, and we'll find the length. So we know the row and column values to here, right? Once we find int nmm, right, we should define the row count and the column count. So let's call int is a array. We are going to create a two array, row count like this, right? and it's nothing but new int, and we'll take m like this. Similarly, we'll take int, this is called call count is equal to new int n. So we have created for both row and column. Okay. Now the thing is, we will count one is in the row and column, right? So let's say, guys, let's count one s in a row, in rows and columns. Okay. So very first we'll take a for loop. We'll say int I is equal to 0, then I is less than m, and I plus plus. Or we'll start int j is equal to 0, j should be less than m, and j plus plus. Okay. If mat at I and j is equal to 1, if this is the case is there, it means we'll say row count at I plus plus and call count at j plus plus. So these two things we will do, right? Row count and column count. If we have one, we'll increment both counts, right? Otherwise, not otherwise, we'll continue the spatial count. We can say the spatial rather than saying that what is the spacer, right? So spatial will start from 0. If we will find that, so let's check the position, right? First means we, once these are done, means row count and column count is done, we will check a spacer. How many spatial position are there, right? I will check. So we know that we'll create the for loop like this again. For will start int I, because we have to scan, right? So I is less than m, and I plus plus will say, inside this will say int j is equal to 0, and j should be less than n, j plus plus. Okay. So these two things will be same because we have to scan, right? Now similarly we'll check if the matrix at I and j, if matrix at I and j is equal to 1, and we will check on the row count. If row count at this position, that is called I, if contains equal to 1, similarly we'll write and we'll say call count. If this call count at I means row and column both contains, count is 1, right? In this case, the spacer becomes plus plus. That's all we need to do. Once this is done, we'll return the spacer. Okay, let me check. Is there any error or not? It's working fine. Let's submit. Okay, so it is not accepting the answer. Let's try to find why it is not working. Very first we find m equal to mat dot length, right? And then we have to the count, right? So these two things we have checked. Now let's think about that. We scan the row I0 to m and I plus plus, j start with the j plus plus. That's okay. So here we have done mistake, guys. It should be n. Okay, let me submit this again. Still we have problem. So very first we have took m and n, that is correct. Then we have took the row and column array, that is also correct. Then we'll count 1s in the row, right? Start with the 0, we'll go to the I and j. I will go to the less than m and j will go to the less than n. I plus plus j plus plus. Matrix and I and j is equal to 1. Then row count at I is plus plus, otherwise call count j is at plus plus, right? Now we have took a special is 0 initially, so we'll check the special position. I is equal to 0, so I is less than m and I plus plus, j is 0 less than n, j plus plus. Very first we check the int ij is equal to 1 and the row count at I is equal to 1, row count at j. This is the problem, guys. So whenever you have the error, you should go one by one and you should check. So it's working fine. So in this video we have understood what is the approach we are going to follow, right, and why this code works. So let's try to understand the time and space complexity. Okay, so let's try to understand how this will work, right? Because we have took two arrays, right? These two. So these two array we have taken to keep only exactly one is we have to take, right? So in these conditions, right, it will take, we are storing the value, right? Let's suppose, because for if the size is m and the size is n, right, it means the for the space complexity, right, we know that we have to store something, right? And that is nothing but O of m plus n, we can say that, right? The space complexity. Let's talk about the these two loops we have created, right? Here we also took, right? So for these, if there is m and n elements are there, right, means the time complexity will become what, like this one. Okay, this is what we should understand. And why we will, but why this code will work, because a row must contain exactly one, right, and a column must contain exactly one, right? So if both condition holds, it must be a special, and that is why we are checking here. Okay, so this is very efficient code, guys. Okay, in case if you're struggling with anything else, please let me know in the comment section. And if you're doing preparation for the FANG interviews and product based companies, you can reach out to me and we can enroll in our online classes. Classes are going on regularly. You can join our classes. And that's all in this video. Thank you. Bye bye. I'll see you in the next one. Thank you, guys. Thank you for watching this video. If you found this video helpful, please like, subscribe, and let us know what you want to learn next in the comment below. And thank you for watching this video.